Hello everyone, welcome you all to this video. So in this video we will try to solve this example number 3. So let us try to read fast and let us understand what are the given data and what is it asking to find out, right? So here it is telling that a mass of 2 kg air is compressed in a very slow process from this much pressure to this much pressure, for which PV equal to constant. Okay, so from this we can understand something. Some air is there which is getting compressed from certain pressure to certain pressure with some process. So process relation is given by PV equal to constant. That means we can tell this is as an isothermal process, because we know for isothermal process multiplication of pressure and volume, it is remaining constant. Okay, and what else given? The initial density of air is also given, so that is rho 1 is given to us, and we know that is rho 1 is equal to what, or rho is nothing but this is 1 by specific volume, that is specific volume. So ratio of specific volume is what? Density. Okay, so if rho 1 is given, then it is nothing but V1 is given to us. So rho 1 is given, that means we can find out the value of V1 by taking the ratio of this density. That means we can write, so V1 will be equal to 1 by rho 1. So simply I can find out this value, right? So here we are given with the value of specific volume, and what is it asking for? So it is asking to find out the work done by the piston to compress the air in kilojoule. Okay, so four options are given to us, so we do not require these options actually. So let us try to solve it. Okay, so what we understood from this question, that there is a isothermal compression process which is occurring from certain initial condition to certain final condition, right? So what are the given data to us? So initial pressure is given uh, and final pressure is given. So let me write down them. So let me erase all these portions. Okay, so we are given with, so let me write down the given data over here. So here press okay, first of all we are given with the amount of mass, that is M is given to us, that is as 2 kg, right? After that we are given with this pressure, that is initial pressure, that is P1, this is as 100 kilopascal. Okay, and P2 is given to us as 70 kilopascal. Okay, then we are given with this process, so process in which this compression is taking place, that is isothermal compression process, right? Okay, and initial density is given, that is rho 1 is given 1.16 kg for meter cube. Okay, and from here, as I have mentioned, I can find out the value of specific volume for initial condition, that is B1, and that will be the ratio of 1 by rho 1. Okay, so this is nothing but 1 by 1.16, and whatever will calculated value, that will be the value of B1. Okay, and we need to find out the value of work done by the piston to compress the air. Okay, and today only we have discussed the formula for finding the work done in a isothermal process. So let us try to understand and derive that formula again. So we know for isothermal process, as this relation is given, this is PV is equal to, let's constant, right? And we know this uh, the equation or net work done, we can say, for any closed system. So this will be equal to integration of state point 1 to 2 and integration of PdV, right? And from here, if we'll be trying to find out the value of P, then we can find out P equal to C by V, right? Okay, so let us replace this P by this term. So we can replace it. So I can write or integration 1 to 2. So 1 here it is representing the state point 1, that is the initial condition, right? And 2 is representing the final condition, that is the state point 2, right? And P will be replaced by C by V, and dV was initially there. Okay, and let us do this simple integration, and if we will be doing so, C can be taken out, and if we will be taking C as a constant, then if we will be doing this integration, that is dV by V, then I can write ln V. Okay, and from state point 1 to state point 2. Okay, so if we will be putting this initial and final conditions, then simply I can write C ln V2 by V1 now. So this is the work done for an isothermal process, and simply we can derive this relation, right? So now there is nothing to do, we are given with all these values, and I know, so we are given with the pressure data. Okay, so let us write this formula in terms of pressure. So we are given that PV is equal to constant, so I can write P1 V1 will be equal to P2 V2, right? And simply I can write now V2 by V1 will be equal to P1 by P2, isn't it? So now let us replace here V2 by V1 by P2, sorry, P1 by P2. So now I can write my equation somewhat like this. So let us write it. So I can write now W1 to 2 will be equal to this C. So I am replacing this C by P1 and V1, the properties of state point 1. So that is P1 and V1, and ln V2 by V1 will be replaced by this P1 by P2, right? So P1 by P2. So now all these values are given to us, and we have to find out the values in terms of kilojoule, right? Okay, and whatever answer we'll be getting from here, it will be in terms of kilojoule per kg, because we have taken here a specific volume, isn't it? Okay, so to get answer in kilojoule, what we have to do, we have to multiply this mass which is given to us as 2 kg, right? Okay, so there is nothing now, we have to simply do the calculation. So what are the values given to us, let us put and try to find out the answer. Okay, so let me write it. So W1 to 2 now can be written as P1, it is given to us as 100 kilopascal. So let us keep it in terms of kilopascal only, because if we'll be keeping this term in kilopascal, then we'll be getting it in terms of kilojoule per kg, right? So that's why I am keeping the pressure in terms of kilopascal. Okay, so P, it is given to us as 100 kilopascal, right? And V1 will be getting certain value from here. Okay, and otherwise directly I am putting this value, that is 1 by 1.16. okay, after that I'll be multiplying this term. Okay, so ln P1 it is 100 again divided by P2, that is 70. Okay, so now to get our work in terms of kilojoule, I have to multiply the mass. So mass is given as 2. Okay, so if we'll be calculating this value, we'll be getting our required answer. So nearly we'll be getting, so let me, I have already calculated the value. So this is 61.4956. okay, and this will be in terms of kilojoule. Okay, so if we'll be checking our options, then we will be nearly matching with option number D. Okay, so option number D will be the correct answer for this given question, right? So option number D will be the correct answer, right? Okay, so hope you understood how to solve this type of simple questions. Okay, thank you.